Hello, my name is Alex Nielsen, and I'll be presenting lab number 6, my lab project for Physics 205. So the purpose of this lab is to demonstrate how an electromagnet works and investigate how the number of turns affects the magnetic field strength. So an electromagnet is a magnet whereby the magnetic field is produced by an electric current versus a permanent magnet which produces a magnetic field all the time. So as you can see here, I have an electric current source with two 1.5 volt batteries, and I've constructed 3 different electromagnets, one with 10 turns, 20 turns, and 30 turns of a copper wire. Now, these electromagnets are in the form of a solenoid, and a solenoid is just a coil of wire. Now, and as you can see though, I've inserted an iron nail in each of the solenoids. And the reason for that is that actually increases the magnetic field strength. So you could have a solenoid with nothing in it, just a core of air, but it would be very weak. And when you flow current through the wire, a magnetic field is produced around the wire, but again, it's very weak. So that's why you need a core, iron core in the middle. So to be a bit more quantitative, the formula for a solenoid is B, the magnetic field in Teslas, equals the mu, which is the permeability of free space, times N, which is your turn density, times I, the current. So in this case, again, if I had simply a coil without an iron core, the permeability of free space would be approximately 1.256 times 10 to the negative 6 henries per meter. So very weak. But inserting a iron core in the middle, the permeability is actually 6.3 times 10 to the negative 3 henries per meter. So that actually gives you a 200 times stronger magnetic field. And the reason you want to use iron as opposed to a different material is that iron is a ferromagnetic material. And so what that does, or what it has, is that it actually has magnetic domains in the material, in the iron, whereby when a magnetic field is applied to them, again, and the magnetic field is produced when current starts flowing through the wire, that actually lines up, the domains in the iron. And the domains are just little regions of magnetic dipoles that are spinning because of electrons spinning. And so once the electric field is applied, all those domains line up, and then they increase the magnetic field that's being generated. So that's why you want to use iron, which again is a ferromagnetic material. So with that being said, let's apply the current and see how strong our current is, our electromagnet is. And again, this is the 10 turn one, so I have the current going. And fortunately, it's not enough to pick up even a small little paper clip. So let's move to the next one. So this is the 20 turn one. And it just seems to pick up the magnet. So the strength is much greater. Okay, so let's see what happens with the 30 turn electromagnet. Okay, so yes, that also picks up a paper clip. Let's see if we can do 2 paper clips. Not quite. Definitely one, but not quite. So as you can see, the strength of the electromagnet increases with the number of turns as per our theory, and that demonstrates the theory and implementation of an electromagnet. Thank you.